Right then, good afternoon, everybody. I hope everybody's okay, friends, family, all safe and well. Could I ask that everybody mute yourself during the presentation? I'm the host for this afternoon. I haven't got control of the setup, so if you could all make sure that you are muted, just as to not interrupt the presentation. So this afternoon's presentation, we've got HK Technologies' very own Mark Covill, about to update you on the products and services supplied by Balance Systems. Okay, over to you, Mark.
Okay. Right, can you all see that? Okay, so there's Mark Covill from HK Technologies, and HK Technologies, we have 6 core areas to our business. We have EDM sales, machinery, additive machinery sales, 3D printers. We have laser subcon marking. We have super finishing, gear grinding, and balance systems, which is what for the next 10 minutes or so I'd like to talk to you about this afternoon. Tell you who they are, what they do, and why they do it. So we'll go for that. So Balance Systems was founded in 1975 by Gianni Triafetti at GT Electronics in his basement of his house near Milan in northern Italy. In 1987, they changed the name from GT Electronica to Balance Systems. As the business grew, they opened subsidiaries in 93 in France, the USA, China, and Germany. Gianni is still president of the company and still works there every day. He's still very much involved. Today, though, they've moved from the basement to a global headquarters, which is still in Milan. There's 2 main areas to the business: balancing machines, which is what we want to look at today. And there's over 3,000 of those machines installed worldwide. And those machines are producing over 1,200 million parts every year. They also have a systems control division. This produces measuring and monitoring systems for spindles on grinding machines. And they also have launched last year the B-Safe, which some of you may already be aware of. HK partnership started with Balance Systems back in 2017, so it's still fairly new in what we're doing. So what I want to talk about first of all is why balancing. So what we've got here is a model, if you like, of what could be a motor in a washing machine or a car or something. And what's happened with this is that we've created an imbalance. So we've added a weight onto the front of the motor here, and we're now going to rotate it. And I just want to show you what happens once we rotate the motor with the balance in place. So some scary stuff there. So what would happen if we just turn parts out like that with that level of imbalance within them? So what would happen is every part that went out there into every machine would have a very high level of vibration, as you can see by the slow motion replay on the left hand side. As you would have heard, it also becomes very noisy. And with the amount of movement that you're getting on that particular part, the bearings on the machine are not going to last very long. You're also creating a very unsafe work condition. Anything could fly off that. It could shatter other pieces of machinery within the working area that the part is in. From that, fair to say, you're going to reduce your machine life, or you're going to increase your maintenance costs. Every part of that vibration is being passed throughout whichever machine that is in, and you're going to need to replace those parts pretty quickly with the amount of work that's going on there. The effects also of unbalance significantly increase and become more dangerous the higher the RPM that that machine is running at. So what is balancing? So with balancing, what we do is the process of reducing that residual unbalance that you've just seen on a rotor to ensure that we bring the level of vibration, the journals, on the bearings within specified limits. So what we would do is rotate the part at speed. We would measure the imbalance that is created by that rotation. We'd rectify the imbalance, and the methods for doing that we'll come on to. We'd then re-rotate that particular part and re-measure it to make sure we're now within the specified limits for that particular part or mechanism. For anybody who wants a bit more on that, an unbalance is measured in grams per millimetre, or gram millimetres, we see at the bottom. And there's a calculation for there for anybody who feels that they'd like to go out and balance some parts later on this afternoon. There is an industrial scale as well. So there's an ISO 1940 standard, which gives different grades of balancing for different classes of machinery. The balance systems, we tend to operate in this area down here. So from G6.3 to G0.4. So they're smaller parts with very tighter tolerances in terms of the balancing. The maximum part we balance up to is 250 kilograms. Now there is at the moment, we were told a few weeks back, there is an acquisition going through at the moment with another Italian company that will mean that Balance Systems, having purchased this company, will then be offered to have a wider range of balancing machines and move into larger crankshafts, etc., and become a complete range supplier for the market. So how do we actually balance a part? So there's two methods that we can use for balancing a part. The first of these is to remove material, which we can do by using a milling cutter, as you can see here, or by drilling, which you can see on this example here. So both of these are able, so we can remove material to create a balanced part, or we can add material. This can be done through clips, simple bit of plasticine, as you can see there. It may be a weld, a rivet, a screw, a staple, as we've shown on there. So all of these methods can be used to balance the part. So just to summarise on that, so there's two methods of balancing, either removing material or adding material. The method that's used will come down to the part, the process, the customer's requirements, etc. But those are basically the areas, the ways that this can be done. We've just done that, sorry. So the second thing to look at is the levels of automation that we can use in terms of doing those processes. So Balance Systems offer a full range of levels of automation, right from full automation, so where the machine is picking the part, is placing the part, is measuring the part, doing the removal of stock or adding of mass. Then the semi-automatic machines, this is where the operator is loading and unloading. The machine is basically doing the rest of the work with the balancing and measuring. And manual. The manual, the operator is loading, unloading, is removing the material. What the machine is doing is telling where to remove the material and how much material to remove. So we offer a full level of automation, from full automation, semi-automatic machines and manual machines, all able to do the removal and the additional processes for balancing that we saw earlier on. We also have two different axes of machines. So we have a vertical axis machine and we have an horizontal axis machine. The vertical axis machine is generally used for disc parts, as you can see with the brake disc on the left-hand side here. And what we're doing here is removing material by what we call on one plane. So we're just moving material from this one edge here in this particular example. On the longer rotor part, which is actually a motor for an electric vehicle, it's now, so it's a longer part, we now have a horizontal axis in the balancing machine. And for this, we correct using two planes. So we're going to remove material in this example, or add material. We would do that on one plane here, this end, and we'd do the same over here. So we'd balance at two planes. So any disc parts, traditionally, we'd balance on one plane. The longer rotational parts, motors, etc., we balance on two planes. In other words, at either end is the easiest way to say it. So in summary, for the product range, we offer a full level of automation, manual, semi-automatic and fully automatic. We can balance correction by adding material, moving material, and we also offer vertical and horizontal axes. So whatever the customer wants, then there's something hopefully within that range which can satisfy and give them the solution for their needs. But what type of products need balancing? So what we've got here is two lists. The first one is electrical components. I'm not going to go through the whole lot because you can see them. But things like armatures, that could be on a power tool. Motors and pumps for washing machines, traditionally they're all balanced. Blades, pulleys, etc. Brake discs in mechanical components. Clutches, turbochargers, all from the automotive sector. Now, what we're looking for out there really with these is customers producing these parts. And these are the customers that we then need to be talking to regarding, can we balance those parts? Because they need balancing before they go out. The effects of not balancing you've seen in the earlier video. But why balanced systems? So balanced systems offer superior balancing quality. So they're high accuracy. Their machines will balance to less than 0.1 gram millimeters. Very accurate machines. They have a touch detection system, which is used for milling and drilling, which compensates for mill and drill wear. So we're always removing the right amount of material to balance the part. We have a fast balancing process. So we have a thing called unbalanced reduction ratio, which sounds quite complicated, but basically it means we get it right first time. And they do that in 99% of the time. So it takes one go to balance a part 99% of the time. We also have multi-station configurations, as you saw earlier on with the automated parts, where we've got the 4-arm indexing unit, high-speed changeover of parts for fast balancing, and retooling of machines. One operator on a single station machine, for example, a machine that is cutting large brake discs, balancing large brake discs. We want to change it to a smaller size disc. That changeover can be done in less than 5 minutes by one person. So it's very quick tooling changeover. The high machine versatility. All the machines are modular, scalable in design. They come with standard or customized solutions. We have a wide range of options which are available, for example, part labeling for identification, QR codes, etc. And the milling correction on the machines as a 3-axis interpolation. So we can move them forwards, up and down, sideways. The other thing that's important when you're removing material, particularly chips, is that those chips aren't going to fly into the machine, cause damage in the machine, or if you've got a part, for example, a shaft with a magnet on it, you don't want those chips then attaching to the magnet because it affects the balancing. So we have a very high efficient extraction system with an adaptive funnel that gives a very high vacuum flow rate, and we can remove 99% of chips from drilling or milling within the machine, so making it very, very efficient. So within the range of machines, we have 45 different machine configurations as it stands at the moment. So I'm not going to go through all those, you'll be pleased to know. But each of those different configurations can be made bespoke to the customer solutions. And with the range that's now on offer, and with I mentioned before about the acquisition which we think is taking place, or we know is taking place of this other company, Balanced Systems will be able to offer a range of machines second to none in the marketplace, quality which is also second to none. So that's a quick overview of Balanced Systems, who they are, what they do, and why they do it. So thank you for your attention, and is there any questions?
I'm Mark. If you could end your screen share, please, Mark.
Yeah, hold on. There you go.
Okay. Thank you very much for that, Mark. Brief overview of balancing systems. Has anybody got any questions currently for Mark based on what I've just seen? Hang on, first up. Lee Adamson, if you could unmute yourself and raise your question, please, sir.
Am I unmuted?
Yep.
Yeah. Okay. Yeah. Okay. I just wondered, Mark, with the amount of machines, how many? I don't think I've ever asked the question of how many we've got placed in the UK of the varieties we've got.
Not many until 2017. They had no operation in the UK, so we picked it up in 2017 when we started. They have a lot of the control systems in place in the UK, but not balancing machines. So the first one that we've got on the project is due to go into a company in Coventry. It was due to be in by now, but for various changes to design, it's due to go in now in, we think, touch wood, October. So at the minute, it's brand new. It's a brand new market. We've got 1 or 2 projects on the go with them at the minute, but it's something that we really need feedback from people to try and crack into the market. We're coming late to it, really, Lee.
Okay, no, that's fine, Mark. It's something maybe me and you can talk a bit more about and getting a bit more in depth when I'm obviously covering the north. So if that's something you want to try and promote, yeah, definitely, that's not a problem at all.
Yeah,
be good to see that one when it's in place, like as well. But, all right, thanks.
Cheers.
Yeah, good presentation. Cheers.
Just to follow on from Lee there, then, Mark. What are the lead times on these machines on average, then, due to the bespokeness of them?
Normally, I say normally, it is for a bespoke machine, it would be 8 to 10 months. For an off-the-shelf machine, like one of the turbocharger machines, they are pretty much 8 weeks, something like that. But for a bespoke machine, you're looking 8 to 10 months. The issue we've had with the machine that is going into Coventry is that the design of the shaft that it's being designed to balance has been changed by their designers on about 4 or 5 different occasions. Right. And that has been some of the hold up on it. There's also been some issues regarding magnetism in the shaft, etc. And it's all been down to design changes, really, Gareth. But normally 8 to 10 months.
Okay, thank you very much. Next up then is Scott Ellesmere with a question.
Hiya, Mark.
Hi, Scott.
Yeah, I hope it's not maybe a silly question, but the removal of material, obviously there's quite a selection of parts there. I take it we're just using, let me say, standard mills, drills off the shelf, or is it something bespoke that they do as part of the package?
Yeah, it depends on the material that they're working on. So what they do is they don't supply, the cutters that are supplied by a cutter manufacturer. So for example, one of the projects we're working on at the minute is they're talking to ISCAR, and they will talk to the cutter manufacturer, and they will get the recommendation from that cutter manufacturer as to what cutters are needed for that particular material. And then the spindles, etc., the drive on the machine will be geared or run at the right speeds for those particular cutters. The other thing you need to bear in mind is that it has to be cut dry. You can't use any lubricants in there, because anything sticking to the part itself will cause imbalance. So it's all done dry. So all that technology comes from a cutter manufacturer. Once we know what the part is, the material is, they will then talk to the different manufacturers and come back with the best solution.
Okay.
Is that okay?
Yeah, no, thank you. Okay.
Are there, has anybody got any other questions? I only had the 2 questions. Okay.
Just one other thing. If anybody's there's two main competitors out there that you need to look for if you're going into anywhere. One is Schenk, and the other one is Hoffman in the UK. Now, they are both really well established, but a lot of their machines must be coming to the end of their lives, and I think that's where we've got real opportunities now. If we can identify those markets and those customers, I think we can push this further, especially with the eyes that we should have out there now.
With that in mind then, Mark, I know Balance Systems have got another product that's specifically related to more directly to ETG, which the ETG technical team have picked up on, which is the B-Safe.
Yeah.
Do you just want to give everybody a brief overview of what the B-Safe is?
Okay, yeah. So B-Safe is a small, if you like, screw bolt size part which can be added to a spindle on a machine, and it is a spindle monitoring service, so it will monitor all the vibration, heat, collisions, etc. on that spindle over a period of time. It will warn you. It's a warning system to say that the spindle needs servicing. I suppose, yeah, it's a spindle monitoring system which remotely monitors what's going on with that spindle. I know Martin's already got some customers. I think Jamie's already done some work with it as well. But in simple terms, that's what it is. It's a spindle monitoring system which can be fitted to any spindle retrospectively, just literally by drilling into it and screwing it in.
Okay. All right. Thank you very much. Have you got anything to feedback on what you know of it, Jamie? Sorry, mate, I put you on the spot there, you know.
Can you hear me?
Yes, mate.
Yeah, no, we have it down in a customer in Limerick, and they do a special process there where they're doing friction star welding. So on the shear-on machines, they're actually welding an aluminium plate to a steel plate together, and then from there we then go around with a milling cutter and we take off the excess material. So we were having a few issues with the spindles, and obviously there has been some back and forth between the customer and supplier who is to kind of like take responsibility of this. So obviously we pushed it back towards the manufacturer, they're pushing it back to the customer, and so we got involved with the B-Safe system, and we've now got that currently tested on one of the machines in Limerick. And as you say, what it does, it gives us good daily feedback on the vibration of the spindle, and also the amount of heat that's generated inside the spindle. And that's important because, like I say, we do the friction star welding, which is a unique piece of application that we've added to the machines, where we're not actually cutting anything, we're actually just using a solid tool to melt material onto material. So you can imagine the heat going through the spindle and then getting into the bearings. So we've had that in there for about 2 or 3 weeks now, and we feed all of this information back to our manufacturer, and on the basis of that, they've actually built and developed a new, stronger type spindle for that application, which we're hoping to test the new spindle in the next 2 or 3 weeks.
Okay. So it's added value to what you wanted the outcome for then?
Absolutely, because like you say, it's, yeah, if that goes ahead and this spindle works out to be the better spindle, we then have to replace all the spindles into the other machines. And obviously that adds value to us, not just from spare parts, but also we do all the installation. So, yeah.
And being able to solve the initial problem that they're
exactly, yeah,
as well, which is excellent. So yeah, there's 2 elements to the balancing systems offering, but one is obviously the balancing systems, as it said in its tip. Anybody else got any other questions? No, must have covered everything, Mark. Okay, if everybody could unmute themselves in and give Mark a round of applause. Well in, Mark. Appreciate it,
Hi, Mark.
Well done, mate.
Okay, on. Cheers for that, Mark. So next up then, on May the 7th, which is Thursday, we've got Steve Howes. Give us a whoop whoop for Mr. Steve Howes discussing Nakamura software. So we look forward to that one, Mr. Howes.
Yeah, you're in for a real treat.
Yeah, good lad. Good lad. Okay, then stay safe, everybody. Look after yourselves. Thanks again, Mark. See you soon.
Cheers.
Cheers.
Bye.